Welcome to our video, naming and drawing hydrocarbons. Hydrocarbon is a substance consisting only of carbon and hydrogen atoms. Hydrocarbons are classified in 4 different types according to their structure: alkanes, alkenes, alkynes, and aromatics. An alkane is a hydrocarbon containing only single carbon bonds.
I'm going to explain to you how to make the alkanes. First, we need to find the lowest carbon chain, like here. And then we will make the carbon chain according to this carbon. We will try to find the lowest number for it. So in this case, we will start 1, 2, 3. So it's going to be the position 3. If we do it otherwise, it will be 1, 2, 3, 4. So the lowest number position is 3. Here, we are going to find the lowest carbon chain. It will be this one. It has 6 carbons, and then we will number this carbon chain according to this carbon. If we do it this way, it will be 1, 2, 3, 4, 5, and 6. It will be position number 4. If we name it the other way, it will be 1, 2, and 3. So the lowest number will be 3. Since it is just one carbon here, it is named meth. So it's a 3-methyl hexane because it has 6 carbons.
An alkene is a hydrocarbon containing a double carbon bond.
Now we will name the alkenes. This is a process similar to alkanes. We will find first the lowest carbon chain. This one. We will start numbering the carbon chain to find the lowest number possible for the low bond. This carbon will not longer matter for us. So if we start numbering, it will be 1, 2, 3, 4, 5, 6. The lowest number possible for the low bond is 1. So 1, 2, 3, 4, 5, 6. The lowest number possible will be 1. And now we have to find where its position in the carbon chain. So it's 4. How many do we have? We have 1, so it's a methyl. So we have a 4 methyl. We have 6 carbons on the chain, so it's an hexane. 4 methyl X. The double bond is in the first position. It's a 1, and since we only have one double bond, it's a heme. It's a 4 methyl X heme.
An alkyne is a hydrocarbon containing at least a triple carbon bond.
Now I'm going to tell you how to name alkenes. First, we're going to look for the carbon chain, which is this one, including, of course, the triple. Then we're going to number near the triple. Then we're going to notice that the carbon is still here. And it is in number 4 carbon. So it's 4, 2, and then we're going to notice where the triple is, which is number 1, and 0.
An aromatic compound is an organic molecule containing a benzene ring.
Aromatic compounds are simply and are like supercanes. And you can write it in 3 forms, like here a benzene ring, or with the 2 bonds in 3 parts, or you can write it like here, that is moving. They have a benzene ring with hexane. And also you can write it here to indicate that resonance, that is the movement of the double bonds. And it's important that you write that there are 3. If not, there will be a cycle. We have the common names that are toluene, the tree form, you said with CH3, like is ortho. Ethyl, and here, and toluene, because the CH3. Or you can use the numbers from 1 to 1 ethyl, 2 methyl, and you need to add the main benzene. The second option is to say only the O-methyl, methyl, benzene.
Now the instructions to draw a hydrocarbon are first, identify the root and suffix name and draw the chain. The parent chain, and the second, number the carbon from one end. Draw the necessary branches of the chain and add the appropriate number of hydrogen atoms to each of the carbons. We're going to start with some examples of each type of hydrocarbon. First are going to be the alkenes. So the first one is 3,4-diethyl heptane. It's a chain of 7 carbon atoms because of the root hept, and with 2 ethyls in the carbon number 3 and number 4. So it's going to be C. Five, 6, 7. Here we can see the parent chain of 7 carbon atoms with 2 ethyls in the place 3 and 4, numbered from left to right. Now the second is 3-ethyl 2-methyllexane. It's a chain with 6 carbon atoms, a methyl in the carbon number 2 and 1 ethyl in the carbon number 3. So it will be CH3, carbon chain of 6 carbon atoms with a methyl in the place number 2 and 1 ethyl in the place number 3. Now the first alkene is 2-methyl-1,2-butadiene. It's a carbon chain of 4 hydrocarbons and a methyl in the number 2 with 2 double bonds. So it will be like this: CH2, one double bond, C, another double bond, so this will be the first one, a butane, because it has 4 hydrocarbons and 2 double bonds in the place number 1 and 2, and a methyl in the place number 3. The next one will be 2,3-dimethyl 2-butene. So it will be like this. Butene, a hydrocarbon chain of 4 hydrocarbons with 2 methyl in the places number 2 and 3. So it will be CH2, C, 2, CH3, 2, C, CH3, it's the same case as one of the alkenes. It doesn't matter if your parent chain is this or this, because it's the same from side to side. A methyl in the place number 2 and 3, and 1 double bond in the place number 2. Okay, so the first one is easy, 2-butene. It's a carbon chain of 4 hydrocarbons and a triple bond in the place in the bond number 2. So it would be like this. C, 1, 2, 3, CH, 3, CH, 3. So the parent chain is this one, and here is the triple bond in the place number 2. The second one will be the 4,4-dimethyl 1-pentyne. It's a carbon chain of 5 hydrocarbons with 2 methyls in the place number 4. So it would be C, 1, 2, 3, C, 3, now we have hydrogen, and it will be as here the parent chain will be like this, or like this, or like this. It doesn't matter, but here are the 2 methyls and the triple bond, and we have our hydrocarbon. The next one is 3-methyl 1,4-hexabiene. It's a carbon chain with 6 hydrocarbons, 2 triple bonds in the places number 1 and 4, and 1 methyl in the carbon number 3. So it will be like this. CH, 1, 2, 3, C, CH3, 1, 2, 3. Aromatics. The first aromatic is a paraxylene. It's an aromatic, so it will have the benzene ring. Let's not look at the benzene ring. And because it has the term para, it means that it has 2 methyls in the place number 1 and number 4. 1, 2, 3, 4. The names are not the numbers are not necessary. So it's a methyl here, carbon, and So this is parasolid. The next one is O-ethyl methylbenzene. The O, it means it's the benzene. The O means that it's an octa and it will have its place. It will have a methyl here and a methyl here. So it's H3, 1, 2, and the ethyl will be here. The benzene ring, so it's an alkyl. And the aniline is a special aromatic that doesn't have a methyl or an ethyl or another hydrocarbon, but it has a special compound that is an amino acid. So it is like this. Hydrogen, nitrogen, hydroxide, something like that. So here's our aniline. It's very easy. Yeah.
Hydrocarbon derivative is a compound of carbon molecules and at least one other element that is not hydrogen.